This is the demo video for some solder basics. Alright, we're going to discuss flux and the use of it, how to maintain the tip of our soldering iron so it lasts longer, cleaning our tip, which we'll discuss in a moment. First of all, tip selection and temperature. Some soldering irons will actually choose the temperature for you based on your selection of your tip. In this case, this soldering iron, this brand is a very popular brand, Hakko. They don't do that. Some brands do, like Metcal and things like that. What I'm doing here is I'm adding solder to the tip of my soldering iron to keep the tip itself from oxidizing. Oxidation will actually degrade the tip of your soldering iron. If you don't see good flowing or good wetting from your solder, it might be because your tip or what you're working on is oxidized. Flux is actually a very good deterrent of oxidation, and that's why we use it. It helps and encourages wetting and stops oxidation on our solder joint and our solder tip and our solder and everything like that. So as you saw, I added solder to the tip of my soldering iron before I set it down. That's general maintenance. You want to do that all the time. Keep solder on the tip. If you're not soldering, make sure there's solder on your tip. And that will increase the longevity of your soldering iron and solder tip. Okay, so I want to talk a little bit about wetting, right? So when wetting is apparent on your solder joint, it typically means that there's a very good and strong solder joint there. So that's what we're going to generally be looking for on every solder joint. To encourage that, I'm going to add a little bit of flux to the pad that we have here on this board. Even that might be just too much. So when you go to add flux to your board, the more you add, the more you're going to have to clean, or your component or whatever you're soldering. So a little bit, I would even say less than that. I'm going to switch cameras here. I'm going to take a little bit of a better shot here. So my solder tip is a rectangular tip itself. This is a very common solder tip that you're using for anything large and even tinning wires. This is a very good tip to use. Solder tip selection is really a personal thing. Whatever you find that works for you is what I would suggest. As long as you're not damaging what you're soldering, you can go as big as you'd like in terms of your solder tip. So I've got my flux on here. I'm going to add a little bit of solder to my tip, which encourages heat transfer. I'm going to set my tip and leave it there. And you can see that just the amount of solder that I added to the tip already starts to flow. As you can see, as the pad heats up and the temperature travels across the pad, the solder is encouraged to move past it. Don't be afraid to leave your iron on things if you need more heat. It's very rare that you're going to damage something. If you're not melting something and you're not damaging the component, you can leave your soldering on here pretty good. The boards are very resilient. I didn't even have to add any extra solder. I had just enough to put on there, and you can see that flow of the solder was very encouraged by the flux. I want to do the same in demonstration that I just did, but with no flux at all. Okay, so check this out. I'm going to add the same amount of solder onto my tip. Okay, and then I'm going to set it about in the same spot for about the same amount of time. You see that? How the solder doesn't necessarily want to flow. A lot of solder wire is flux cored. So if you add a little bit of solder to that pad, the flux that's inside of it is going to encourage it to flow. You can also encourage it to flow physically. Just by rotating and moving around. And a nice tinned solder joint. Okay? But you saw the difference, right? What? The difference of and importance of flux versus no additional flux. Okay? And I'm going to be setting my soldering iron down here. So I'm going to completely encapsulate the tip of my soldering tip and solder before I set it down.